Okay, today we're going to talk about inequalities involving absolute values. We've already done absolute value equations, and if you remember about those, there was something that we had to do that was unique, and that's the first step here is we're going to solve each inequality twice. Okay, once for a positive answer, so we'll just basically take the absolute value bars off and solve it just like it says, and then we're going to solve it again for a negative answer, but since we're going to make that answer negative, we're also going to switch the inequality sign when we do that. Then we're going to graph both answers on a number line like a compound inequality, and we've been doing that. We've been working with compound inequality, so that shouldn't be a big deal for us. First thing I want to do is take a look at an example of an AND compound inequality. And so this one is absolute value. We have the absolute value of m plus 2 is less than 11. So that first step was to solve it twice. So the first thing we're going to do is just get rid of the absolute value bars and solve it for that. Then we are going to change this from a positive 11 to a negative 11, and when we do that we need to switch the direction of the inequality sign. So we're going to solve it once for m plus 2 is less than 11, and we'll solve it again for m plus 2 is greater than negative 11. On this side we're going to go ahead and we're going to subtract 2 from both sides, and that will leave us with m is less than 9. Since it's m is less than 9, we'll put a circle on 9 and we will shade it to the we'll shade it to the left. Okay, then on our next one, where it's m plus 2 is greater than negative 2, we're going to have the same inverse operation. We're going to subtract 2 from both sides, and this time we're going to end up with m is greater than negative 13. So again, we'll put a circle on negative 13, and we're going to shade it to the right this time. This is an AND, so this is the overlapping of these two. So we're going to go ahead and we're going to put on the graph of m is less than 9, and we'll go ahead and we'll put on the graph of m is greater than negative 13, and the overlapping of this is our solution. So our solution is an open circle at negative 13 and an open circle at 9 and shaded in between. That means any number in between these two will make both of these equations true, or these inequalities true, excuse me. Okay, let's take a look at an example of an OR. This one, same type of problem except it's a two-step. So we're going to take the absolute value bars off and solve it just like it is. 3n plus 6 is greater than or equal to 12. And then we'll change this to a negative 12 and switch the direction of the inequality sign. So now we have 3n plus 6 is less than or equal to negative 12. Let's go back over here and solve it for positive 12 first. We're going to subtract 6 from both sides. That will give us 3n is greater than or equal to 6. Next step is to divide by 3. When we divide by 3, we get x is greater than or equal to 2. So on that one, we're going to put a solid dot on 2 and we will shade it to the right. Okay. On this next one, we're going to subtract 6 from both sides again, and that will give us 3n is less than or equal to negative 18. Next step in isolating n would be to divide by 3. We divide by 3, and that leaves us with n is less than or equal to negative 6. So we would put a solid dot on negative 6, and we will shade it to the we'll shade it to the left. And then it's just a matter of putting these both on the same number line. So we've got n is greater than or equal to 2. We have n is less than or equal to negative 6. And the solution would be both of these, okay, because either one, this was an or, so if the number is less than or equal to 6, it's a solution. Or if the number is 2 or greater than 2, it is also a solution. Okay, I'm going to stop here. I hope this gives you a good example of the absolute value inequalities and the two different types, how to solve them, and how to graph them.